Hello, everyone. Welcome to my talk. Now, this talk has some interesting origins. In the past, I was helping Timescale out with some of their developer relations. And one of the things that came out of that was the usefulness of Timescale's approach to dropping chunks and the impact on concurrency. This talk is in part about why this addresses an important user need, but it is also about why we, as a community, we can't go that direction, and maybe some ideas on what we can do instead. Because frankly, at least in my experience, a lot of our approaches to transactional DDL can, how shall we put it, fail whenever you need them to actually work. So I think we have a long ways to go in making that more useful. And as I say, I have some ideas on how to go about things, but some things like create index concurrently may be a little bit more complicated than just simply some of the ideas that I'm presenting here. So for those of you who might be from adjacent fields, DDL of course stands for Data Definition Language. And when we're talking about concurrent DDL, we're talking about being able to, say, change the definition of a table or create an index while we're also using that table in ways which otherwise we would have some trouble doing in accordance with our previous logging strategy. Hold on one second. Putting the did manage to forget to set this up on the clicker. So basically, I've been using Postgres since 1999. There are plenty of people at this conference who have been using it longer than I have. But I have done a bunch of things with it. I've worked as a database administrator, developer, and have also contributed one bug fix to Postgres some years ago, and am working on some potential other contributions. Also write a lot of extensions. So basically, my view is that concurrent DDL on Postgres is something right now that often doesn't work when you need it to work most, right? If you've ever tried to create index concurrently on a highly loaded database, chances of actually getting it to complete in a timely manner, it's iffy except in very specific workloads, right? Go ahead.
There was presentation at PGCon last session about exactly the same
Yeah.
and how it led to multi-hour downtime.
Yeah, that was Tim's presentation. I was there. It was a great presentation about how they tried to use create index concurrently, and it led to multiple failovers and different systems in different states, and eventually they ended up having to accept data loss because they tried to do create index concurrently and it totally messed up their replicated cluster. So yeah, this, the problem is, though, that concurrent DDL is actually a much harder problem than it often looks like it is on the naive surface. And when I start looking at specifically, for example, the shortcomings of Timescale's approach, we'll start seeing sort of why doing this in the general purpose database engine, the math engine that everybody's going to rely on to be always correct, is a significantly hard problem. And so, yeah, that's, so this isn't something that is super easy in many cases, but it's something where, like a lot of the problems we think about, or when we read the hackers list and we're trying to understand, for example, why a particular decision was made, oftentimes the actual underlying problems are much harder than the details that get discussed on those lists. So basically, what I'm hoping to do in this presentation is to talk both about why Timescale's approach solves real problems for real customers and doesn't cause any real problems within their use case, why we can't follow that direction because it would in our case, and also maybe some other things we could do to try to make things better. So the major issue here is partition management. And this is something where I've seen outages occur because of locking, right? The typical issue is you have to create partitions and you have to drop partitions. And both of those things in standard Postgres require really heavy locking strategies on the entire partition tree, right? So you're going to have a hard time querying the database while at the same time you are you're trying to attach a table or you're trying to detach a table. And for this reason, what often happens is either you never get the lock if you're trying to time out and retry and you run out of space and now you can't write, or maybe you don't time out and you just wait for the lock and all writes and reads are blocked on the table. I've seen, as I say, multiple outages, multiple places I've worked because of difficulties with partition management and locking. So this is a very real problem. It's a very significant problem, and it bites a lot of people very frequently. Similarly, if you're trying to detach or drop a partition, you also need those locks. And while these operations are very fast, it's important to remember that they block all access to the table while they are waiting to get the lock. So either you have a choice of, oh, I'm willing to block it for up to 2 seconds, and then we'll go back to the end of the locking queue. Or you have a choice of maybe using something like Partman, which we'll talk about later. Or you just go for the lock and accept that it's going to block access to things. And for example, when I was working at Delivery Hero, we had several outages specifically caused by long-running analyze runs. Analyze should never be long, right? But due to some oddities with how AWS Aurora worked and some funny glibc issues on those Aurora instances, we had analyze runs taking 6 hours. And if you're just naively trying to drop partitions, guess what happens? Those runs will typically overlap, and you're never going to be able to drop a partition. It's going to be a problem. So these are big headaches, and the primary problem here is, again, to drop a partition or to add a partition, we have to lock the parent table. We have to lock the parent table because planning needs to know about the existing partition list in your current snapshot, right? And so you have issues of, for example, serialized snapshot isolation level, where we need to make sure that these operations can happen transparent to a query that might be running on an older snapshot. And so if that has ever queried that table, we have to wait for that transaction to complete. Otherwise, we can't properly serialize things in, right? So the locking issues are there for reasons, and we break them at our own risk. So as a visual, here we have a partition tree. That when we drop the partition, we lock the parent table and we lock the child table in with access exclusive mode. In other words, we're not going to allow any reads or any writes to either of these. And effectively, this blocks any query that's going to hit this partition tree unless you're querying individually the underlying child tables. It used to be that the access exclusive lock would actually propagate all the way down to all child nodes, to all child tables. And that was even worse. But they've decided, that this approach is safe. It's still something, though, that causes a lot of headaches. So Detach current, so we have an alternative, and that's detach concurrently, okay? Detach concurrently does as follows. It takes a much lighter lock on the parent, share update exclusive lock, and then what it does is it updates the catalog entry to say this partition will no longer be part of the partition set as of a particular transaction ID, okay? And then once the transaction horizon has advanced beyond that point, it can finalize that decision, remove the catalog entry, and now you're free to drop the table without propagating the lock all the way up to the parent, right? Now, the difficulty here is that the way that this works in the terminal or with a standard database connection is that your session will basically wait for that transaction boundary to go to the, to basically clear. And so if you have any long-running transactions, you're going to be sitting there for a long time, and your session might drop. Fortunately, in this case, there is an option to finalize it once that transaction boundary has been filled, but that's a lot of additional administrative complexity that we probably don't need to actually hand to the administrator, right? And this sort of gets at one of my big complaints here, which is that dealing with concurrent DDL in our current format is painful for DBAs, okay? You have complexities of cleanup. You have a lot of stuff that really we should be able to do behind the scenes, but we don't, right? So you can, of course, use another tool like Partman, right? And Partman will try in the background to create partitions and drop partitions, and there's a lock timeout and back off and all the rest of this. It helps managing some of the complexity, but a lot of the complexity is still there. And consequently, if you push your system hard enough, you may never get those locks, and therefore the partition management may never happen. And then you're going to have to make some very, very hard decisions in order to keep your application up. Go ahead.
Can you just go into more detail on under what circumstances
Sure.
the session has to wait longer when that XID gets set?
Well, it doesn't have to wait longer once the XID gets to that. Okay, so what matters is the oldest running XID, right? And so I've worked in environments, and I kid you not, where we had open transactions for business logic reasons that were open for 14 days. Okay? And the reason they were open for 14 days is that you typically had some job management stuff that needed to be done. Then we needed to make sure the job completed before you committed that. And when you are assembling genomes out of raw data, that can take a lot of time on a lot of computer systems. So
I don't really mean that. I mean, you have lots of sessions connected. Some of them are long running.
Yeah.
You go and you say, I'm going to drop this partition.
Yes.
Later. Here's the XID.
Right.
What I'm wondering is who gets blocked by that?
Only you do.
Touching the table at all, you assume they can just do whatever they want. They're not blocked.
So if,
Somebody's only touching the other partitions in the table and not the one that you're going to drop. Do they get blocked?
no. So the basic thing is, well, no, okay, we're talking about detach concurrently, right? Detach concurrently doesn't block anybody, but you wait for everybody else to get to the point where you can.
The person who's trying to detach.
Yes, exactly.
Thank you. That was
Yes. So yeah, that's the problem that happens there. So Timescale, so Partman, as I say, helps with this a lot, but the complexity is still there, and you need to understand it, because if you push your database hard enough, you'll run into the same problems, and Partman won't be able to do what it needs to do. So Timescale's approach to chunk dropping, basically they have their own planner hooks for planning and everything, and those planner hooks see table visibility through different rules than the Postgres planner does, right? They see current snapshot. The Postgres planner, I think, has its own snapshots for planning, if I understood correctly. So when Timescale drops chunks, it removes a few things from its own internal catalog handling, and then it just simply drops the table. and it circumvents a lot of the locking that Postgres does. This allows an access share lock on the parent and an access exclusive on the child. Okay? This solves a big operational problem for a lot of people. It has, of course, some limitations. I'll get into that. But very basically, because they have their own custom planning hooks, and those see things with different visibility rules, they're able to make this work for read committed transaction isolation, and most of the time for serializable. Now, I said most of the time. I'm going to get into that in a moment. Okay? In the naive cases, it all works. If you try hard enough, you can break it. Mm-hmm.
There's an access, read lock put on that child.
Mm-hmm.
Not on the other.
Yep.
Just the one you're trying to drop.
Right.
Also on the parent.
Yes.
So if I try to read or write from one of the other children through that parent,
Mm-hmm.
is it locked?
Yes. You cannot even plan.
There's no data in that parent. Why would there be a lock?
Because you need it for because of the way the planning works, and I'll describe. So it took me a long time to figure out how to break Timescale's approach in serialized snapshot isolation level. But the very basic issue is that you need to be able to. Okay, so you're modifying stuff about where you actually go ahead and read and write data, right? And when you do that, if this is changing out from under a running query, or a query that's currently being planned, bad things can happen. So you need to make sure that the visibility of the partition series is consistent within your existing query plan and execution, right?
You're changing the routing through the parent table.
Yes.
So if the planner doesn't have visibility of that.
Exactly.
Okay. So then you lock the parent and the child.
Mm-hmm.
You could still potentially directly hit one of the children.
Yes.
And get that routing over to the parent.
That's correct. Yeah, you can definitely write to the child directly, but you can't write through the parent. Yeah. So as I say, the key thing for Timescale making this work is that they have their custom planner hooks, and those have different visibility requirements when they actually go and do the planning. Okay, so that's so my first thought was, wouldn't it be great if we fixed our visibility? This is obviously a problem with our visibility mappings, right? If we could fix our visibility mappings, we could get rid of this problem. Well, not quite so fast. Problem solved. Therefore, you drop chunks, and everything just works. It doesn't block the parent. However, there are a couple of very specific problems that happen here. Okay, and overall, for many customers, this solves a bunch of big problems, right? For many customers, this means you no longer have to worry about lock contention when you're dropping data. And remember, you're normally dropping partitions when you're no longer using them, right? So you're not going to use this data anymore. You can just drop it. Everybody's happy. I used to think we can fix Postgres, we can be more like this. It took me a long time to realize why I was wrong. Downsides. This is something that has been a significant source of bugs within the Timescale code base, right? There's a lot of maintenance that goes into this and a lot of thought, and it's a difficult area to reason about, things like that. That's actually the smaller of the problems. But the larger one from our side is that if you try hard enough, you can get data anomalies in serializable snapshot isolation mode. And the reason is that because the planner visibility stuff will now no longer see the dropped chunk properly, you still run into a problem where in the event where you drop the chunk and you also do some other manipulation of data within, say, the partition set within the same transaction, you can run into cases where we're trying to serialize these will end up serializing part of the transaction before your current query and part after. Okay? Which means you will see an inconsistent snapshot. Okay? It is ridiculously hard to do. It will probably never happen in the real world, but it is theoretically possible, and once it's theoretically possible, you can bet that at some point somebody will do it, right? Now, again, this whole thing has to do with the fact that when we're planning, we see that the partition's gone, but we may, in fact, at the same time, be at the same time be serializing the transaction in a different order, right? In the real world, for Timescale's use case, this is not a problem, and it's not a problem for us for Timescale to do this, right? Why is this not a problem? First of all, databases exist in the real world. We all know that, right? Of course, as database developers, we can't rely on that. And in Timescale's case, these are almost always being used for analytical queries. Nobody's running serialized snapshot queries on old chunks, right? And even if they were, the dropping of the chunks is usually handled in the background by a process that does nothing else. So you don't have the serialization problem. Okay? So in the real world, this is probably never going to happen. And even if it does, the answer can be, don't put that data on Timescale, right? Use Timescale for something else. Don't put that data on there if you're going to use it that way. Problem solved, right? This gets to a fairly big issue, right? This is a problem of ecosystem. We're building the math engine that has to always be correct. Timescale is building a product that solves specific problems for specific customers, right? They are free to make certain kinds of trade-offs that we're not, right? And if we start making these trade-offs, one of the big fears, a very completely legitimate fear, is that we'll get complacent about things like this, and we'll go, oh, this will never happen in the real world. You know, serializable isolation level doesn't really have to account for these corner cases, and those corner cases will propagate until it's not usable anymore, right? So we can never go this direction, right? But we can also be relatively happy that they are, that they're showing that there is a need for certain kinds of solutions to some of our problems, and then we can try to figure out what we can do to address those needs in a way that's correct and usable for everybody else, right? So the problem that Timescale is addressing here, in my view, is that DDL concurrency is painful, right? In the event where you're trying to create indexes concurrently, you have a very good chance that you're going to fail and you're going to have to go drop an invalid index and try again and maybe do the same thing and try again and try again and try again. And especially if you're up against a time crunch, that pain may be very serious. Or in the case of the talk that Tim gave at PG Day Brussels, it could actually create much, much worse problems up to and including data loss. So create index concurrently, in my view, is pretty fundamentally broken. But coming up with a completely working solution is still non-trivial. And that's probably something that we'll end up having to have a lot more conversations on in order to get there. But like if you detach a partition, then you still have the waiting period, but if you fail, you can go and finalize it later, right? And that's less painful, but it still adds a lot of complexity to partition management, because now you have to be prepared for a failure of detaching the partition. You have to be prepared to handle that, clean it up, and you've turned a drop partition statement into a 3 or 4 stage process, which is going to be spread among many transactions, right? I think we're still in the process of figuring out how to solve this problem. And in some cases, it's a lot easier than others. So at this point, I really want to talk about real versus fake problems here. Because if we start going, we go through the hackers list and we read about the decisions made for why we drop concurrently in the way we do. A lot of this talks about the safety of purging rel cache. That's not actually the problem, okay? That's a very small symptom of a much, much deeper problem. And so when I say fake problems, a lot of times that we get distracted when we're talking about how to solve these problems in a larger way by the implementation details rather than the much larger functional problems that are mathematically tied to this problem domain as a whole, right? Because in theory, any DDL transaction could be made concurrent to anything else, right? We just need to make the cleanup asynchronous and, drop database concurrently, and, when the transaction ID goes around, we can just drop the database and everybody can go, you're no longer connected, right? Probably a very bad idea. I would never, ever, ever recommend that we ever do something like that, right? But in practice, the fundamental problems have much more to do with we have to keep data around so that we can properly handle these serialization questions, right? Simply purging the rel cache entries isn't safe because then you could go drop the partition and you might end up in cases where you cannot detect that you cannot safely serialize transactions in a proper order, right? The first problem you could possibly solve by fixing how we do rel cache. The second problem cannot be solved, right? Because it's fundamental mathematically to the problem in hand. So that's what I mean by real versus fake problems. We have implementation problems, but a lot of times those implementation problems are symptoms of more fundamental problems that cannot be solved. So if you fix the implementation, you still can't do it anyway. There's no point in trying to fix that implementation bug or implementation obstacle. So what I want to do now is I want to talk a bit about a possible path forward, and then I will take some questions. I think one of the ways that we currently think about concurrent DDL is we think about everything as being in 2 states. It's either valid or it's invalid, right? It's either taking effect or it's not taking effect. And then what we do is we basically block the user session that's trying to make this change until it can be made valid. In my view, this prevents us from doing a bunch of things that would make this whole process easier. And so what I would propose is that we rethink sort of the state diagram of concurrent DDL statements so that we have an intermediate phase where we are waiting for transaction ID horizons. Because your cleanup considerations, et cetera, are different at different stages here, right? If I'm trying to attach a partition concurrently, or if I want to, I could create a partition concurrently, I could, then this could all be done in a way in which would be waiting, and therefore transactions beyond a certain point couldn't see them. We could hand all of that off to a background worker to just do this final accounting, right? Additionally, we could when we start up Postgres, we could check for waiting DDL stuff, and we could just finalize them, right? Because at that point, we don't have concurrency problems. But we can't do that if we don't have a clear and complete sort of state diagram of what's valid when, right? So that's, I think, the first thing that's necessary. The second thing is, I think that we really need to rethink how create index concurrently works, because you have some additional considerations there with how vacuum works and stuff like that. So an example that we could eventually come up with a drop partition concurrently would be that that basically you make the same changes that we make today for detach partition concurrently, and then once we're in that waiting stage, which is going to happen really quickly, we hand it off to a background worker. When the transaction ID horizon gets high enough, then it could not merely detach the partition, it could then go ahead and clean it up and delete the relation files. We could have all the information in the catalogs that we could determine that that's the case when we start up Postgres even. We could say, oh, this is now ready to be dropped, and we could clean up the files at that point too. So this is probably the easy case here, right? Now, create index concurrently, I think I'm probably missing some details on it. I would love to hear from people, either in the question and answer session or afterwards, about what I'm missing here. But my mental model of this is that indexes don't contain visibility information. So we could just, all we really have to do is make sure that the B tree is pointing at all the properly unvacuumed rows, and that when you vacuum it, that the B tree is maintained properly anyway. So from my viewpoint, the simple naive solution would be backend could make the connection, basically create the index. At that point, it should be maintained by other processes as an invalid or as a building index, created in a building state. Then you backfill it all, and you basically have a transaction ID, or you might have to have some sort of lock to prevent vacuum from running on that table during that building stage, right? Because vacuum at that stage may be a little bit dangerous, right? Once that's done, then you could change the state to waiting, hand it off to this worker, and then once the transaction ID horizon gets high enough, just simply mark it as valid. And during the waiting stage, then vacuum could work normally, right? Because you're no longer backfilling and you don't have the complexities of all that. So that's my naive approach here. I would love to hear from people about, what I'm missing, because I'm probably missing something and I don't completely. So the key thing here is people actually really do need solutions for these problems, right? They're common causes of Postgres outages, and they're common causes of service outages among at least some of the larger users that I have worked with in the past. Solving these problems, including with these corner cases in the serializable snapshot isolation level, is valuable enough to some users, or most users, that the trade-offs that a product like Timescale makes is really, really, really helpful. But it's not a general solution, and it doesn't get everybody everywhere, and so we can't do it in core. So then the question is, what can we do to come up with a system that works well enough that is no longer the trade-off that people are going to find very, very compelling? And I think we have a lot of work to do there. So I think that if we can come up with some really good solutions on that, I've outlined the way I think some things could work here. I think that we could quite possibly make Postgres a lot more useful for a lot of people. So I'm opening this up to questions now. Go ahead.
So one of the problems we have with create index concurrently is it doesn't work in a transaction. Would any of this, is that the way it's always going to be, or?
So I think the reason why a lot of these don't work in transactions is because behind the scenes, they're operating across multiple transactions, right? Because everything in Postgres operates in a transaction, but a statement itself, like create index concurrently, may require spanning multiple transactions. And I think that being able to have a better state diagram and ability to hand this off might make it easier to put it in a transaction, right? Because then at the end of the transaction, you're in a state where the index is in a defined state that is now usable for vacuum and things like that, and it can be maintained by something outside the transaction. So I think we could solve that problem. I don't see that as something that is fundamental to the issue. At least that's my naive view. I may be missing something. So, go ahead.
So, when I think about your naive approach to currently indexing, I noticed that the way I built the index is not the way we used to build indices, but we, depending on where we start, we might get a very unbalanced index if we just insert the tuples one by one. So I'm not entirely sure this is really an approach I would want to go, because the resulting data structure might not look like what I really want to do. And there's also probably some stuff about off-pinning we need to think about, but I think the underlying problem I see is that there's some weird semantics.
Do you think that it would be possible to basically rebalance the B tree at the end of it without?
So honestly, I'm not smart enough about that. Ask Peter.
Okay.
This is what I do about that. I have a question. Have you ever thought of, because this is something that I sometimes wonder, because you mentioned the use case that a lot of customers don't really need that, and on my experience, a lot of customers I deal with also don't need, practically they don't need serializable at all.
Mm-hmm.
So the thing I was wondering whether it might be possible to have like a cluster-wide GOC, like capturing information that like on this cluster there can't be any serializable queries. This would allow us to do a lot of logging improvements, I think, in some cases. I was wondering whether this would work if we have such an option to improve logging for customers who really don't need it.
Yeah, I mean that's so this idea of having a GOC that would basically disable serializable snapshot, whether it's on a database or whether it's on a cluster, that's kind of irrelevant because we don't usually care about concurrency between databases on a cluster, right? But it's an interesting idea. I think it could have some real merits. The one thing I would worry about in that case is that if you have a whole bunch of locking improvements which are conditional on serializable snapshot isolation level not being available, then now you're maintaining two code bases of lock optimizations effectively, and there's going to be a lot of added complexity there. And so I'm kind of wondering, so like the concern I would have is that if there are a large number of those, then it might make the code base a lot more difficult for people to maintain, get into, and help make improvements on, or it might make it much easier for somebody to screw something up. That would be the one downside. Yeah.
I know precisely what you're talking about.
Yeah. Well, I mean, parallel query is another thing that I have experience fixing bugs in that area, and it's painful. And the code in that area, I mean, the Postgres code is usually really, 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 really good. The code in that area is difficult to reason about, And I can't tell whether it is a question of heavy optimizations or, I mean, obviously they decided certain things were more important than clean APIs. So, yeah, I mean, the parallel query stuff is a really good example of how this stuff can become a mess. Any other questions?
And so assuming that it will be working and you will have this backup worker or workers finalizing this, do you think that you will need one worker which will be able to deal with many, with all of those finalizing steps, like
Yeah.
indices or partitions or whatever else we want, or separate workers, and then how we will manage this as DBA, for example. I start some of the stuff, the partition creating the relative, and then I will still sampling to see what finished, what haven't finished, and when somebody calls from management, why this query is still slow, or why
Yeah.
why I don't get step, or then I need to check, okay, this index is still haven't finished.
Right. So, so in terms of this question about how do we monitor progress and do we need multiple background workers? I'm going to start with the multiple background worker piece. If the only thing the worker is doing is transaction ID accounting and the final cleanup, then I think one background worker would almost certainly be enough to be able to do pretty much everything you need to do. Because if you're creating indexes, all it's doing at that point is some final accounting. And even if you have something like drop a partition, which would require like physical file removal, unless you are trying very hard, it would be difficult to overwhelm a single background worker. As far as visibility and being able to provide information in support cases, I think that this would be something, because the information will all be in the catalogs, that having some good views around that would make that problem much, much easier to solve. So the thing is that each of these steps is transactionally applicable, right? And so you would be able to basically, it would be reasonable to have a view that would give you the state information of all of these.